Welcome. This is Ian Knight. Before we start this presentation today, I want to tell you a little bit about me. I'm an old guy and I'm an Australian, and I live in Germany. Well, Holland and Germany. I worked for SKF for 35 years, so I've had most of my working experience in the bearing industry, always in the area of sales, service, condition monitoring, reliability, management in both division and people management and marketing, and in the last few years, training of the senior sales people in the organization. In 2003, I wanted to do something for myself. So I started Enluse BV. Enluse means, it's a word shortened for environmental lubrication and service. And the purpose of starting Enluse was to develop the oil safe market in Australia. The original oil safe manufacturers were Australian, and I, being Australian, they found me in Europe, and they asked me would I be interested to help them grow the oil safe business in Europe. Today, I would say that oil safe is more or less an industry famed name in Europe. It's got good coverage, but there is still a long way to go. I'm also a core developer of the Lustor lubrication storage and conditioning system. This system was sold a few years ago to Oil Safe, so it's now an Oil Safe product. I'm also a co-founder with Ton van Grundebeek of the organization called Lubritech, based out of Belgium. There we supply a lot of lubrication systems and lube rooms directly to industry. The core competence of our company is really something we call lubrication reliability. And it's really putting together all the strategies to reduce wear. In other words, by using good lubrication practices, we can reduce wear, improve uptime, improve bottom line performance. So today, this presentation is about getting the fundamentals of lubrication reliability in place and starting with the lube room. Because if you put the lube room in place, you've got 90% of the fundamentals for the rest of the strategy. Okay. Wear, what is it? So just looking at it from a DIN perspective, wear is the continual loss of material from the surface of a solid body due to a mechanical action. In other words, contact or relative movement of a solid, a fluid, a gas, or a counterbody, and it reduces material. The material removed by wear process is designated as fines. This is the fundamental. So if you take the little graphic below of the ball sitting on a solid plate, with a lubrication film, they're never touching. They're separated by the lubrication film. And this is what lubrication is all about. If you don't have that separation, you have metal to metal touching and you have wear. Another way to look at it is from Professor Rabanowski. I have difficulty with professor's name. He's a professor at the Massachusetts Institute of Technology. And a few years ago, he said that 6 to 7% of the gross national product is required to repair damage caused by mechanical wear. What does he mean by that? He means the cost of maintenance, the loss of usefulness of production equipment. And there are 3 sections he highlighted generating 80% of that. One is product or equipment obsolescence, where it simply gets old and has to be replaced. Damage caused to the equipment through any form of operation, 15%. But the biggest component of that is 50%, which is mechanical wear. And mechanical wear can also be chemical wear, corrosion. But if you look at mechanical wear, there are 3 types of mechanical wear. There's abrasive wear, where surfaces are rubbing together. There is surface fatigue, where the surfaces get damaged and fatigue. And there is adhesive wear, and adhesive wear is microscopic welding of metal components touching. And it comes across as smearing, a very polished surface. But if you take all of those three components and you take the chemical wear, they're all predominantly related to lubrication issues. You have you have particle contamination, too many particles in the, or dirt in the oil. Maybe you've got the wrong lube. Maybe the lube is damaged because you've mixed the lube. It's lost its chemical properties. You've got water in it, or it's just poor quality lube. And this is where we're going to focus today, on these lubrication issues to support the elimination of wear. And as we can see from what Professor is saying, if we can do this, we not only save a lot of money for the company, but we save a lot of money for industry alone. Let's look a little bit more about wear. When I worked for SKF, we always talked about bearing failure statistics. And these were statistics that were put together over years by looking at bearings that were returned to the SKF Swedish Service Center. And we refined them a little bit by time, but we never really did major issues to confirm it. And in 2000, I think 2006, 2007, I was doing a reliability project within a cardboard corrugator plant. And I looked at every bearing that was taken out of the plant over a period of 1 year. The picture you see on the bottom right-hand corner is a picture of all those bearings. And I can tell a story about every one of them. And I looked at every one to see what were the reasons why those bearings were taken out of the equipment. And I found that over 60% of them were related to lubrication issues. I also found that 15% were due to poor maintenance. They were fitted wrong, sometimes with a hammer. They were over-adjusted, they were under-adjusted, just wrong maintenance, or you could say ignorance issues somewhat. But 5% were pure ignorance. They used the wrong bearing. Instead of a C3 clearance, a standard clearance, instead of a rubbing seal, a metal seal, and 15% of them were in good condition. These were real failures, and they were very close to what the statistics we use from SKF were and what the global statistics today are of why bearings fail. Here is one good example of an ignorance issue. I got this from my very good friend, Per-Arne Alquist, who's also in this seminar, has a good presentation, and I recommend everybody should listen to it. This is a bearing that lasted 2 weeks. It cost $50,000. It was a trunnion bearing in a large cement kiln. And you can see on the raceway, you had these radial marks. These are smearing marks. This is an indication of lubrication problems. And there is great wear within the bearing pockets. And you can also see the similar radial marks on the rollers. What happened here is that they fitted this bearing, and they fitted it with a standard grease, the type of grease you would have in the wheel of your motor car. This bearing is highly loaded, it's slow rotating, and it needs a special grease with special fillers to protect the lubrication film, stop the metal-to-metal contact. But the bearing failed in 2 weeks. It cost $50,000, not to mention how long it took of lost production for them to repair the bearing or to replace the bearing. So here is a typical example. And you can see examples like this from this size down to the size of your finger every day. Another way to look at dirty oil is the research that have been done by those people that have done research on the effect of contamination in oil to bearing life. ISO, and this was well known way back in the 80s, as SKF were doing a lot of work in this area with the development of the new life theory as a result of. But ISO have a process of measuring or defining the standard for contamination in oil. and it's called ISO 4406, and they measure the amount of contaminants in 3 micron, 5 or 15, and this has varied slightly over the years, in 100 milliliters of oil, and they allocate a code to it. So if we take a code, an ISO 4406 code of 221813, which could be a pretty standard code in a gearbox, or a brand new oil can also be this level of contamination. And you can clean up the oil to a best practice standard for, say, a hydraulic system of 16-12-8. You have an increase of 4 times the mean time per failure of hours. In other words, you're going to increase the life of that operating equipment before failure by the factor of 4. Another one I always like to use and to refer to is the work that Dr. McPherson did from Westland Helicopters, again, back in the latter part of last century. Dr. McPherson measured the particle size of a filter with a beta ratio of 200 to the millions of cycles to fatigue failure. And what he's really saying is that if you've got a 40 micron filter filtering the oil, which I call a rock catcher, because that's what it is, you can see that it has a very little life, as compared to if you have a filter rating of 3 micron, you've got infinite life. And what's the relationship? The relationship is that the lubrication film thickness in itself is only a few micron. So if you can reduce the contaminant level to a smaller size than the average lube film thickness, you have an ultimate bearing life, or an infinite bearing life. And this explains it a little bit more. If you take the load zone between a ball and the inner raceway of a bearing, it's separated by the lube film, which here we call the lube film thickness. Now, this is very small. It's only a few micron. So if you pull a piece of hair from your head and you put it under a microscope and you divide it 20 times, 1/20th is the thickness of the lubrication film. Now, if you've got a piece of silicon sand floating around the atmosphere, which is very common in industry, in a lube room, and you can't see it, and it's hard and it gets into the bearing, that's a little bit like driving your car over an enormous rock about 1 meter diameter. It has the same effect. It causes 3-part abrasive wear and metal-to-metal contact, ultimate damage. This is another graphic that I've worked on a lot myself over the years. And what it says is that there are 3 phases in a bearing life if it's subject to dirty oil. If you take a plant, and a plant's got thousands of bearings operating in the plant, and you're not filtering the oil in the equipment, you have a process undergo where the bearings are wearing out. When the bearing gets to the point where you notice that it's worn, it's gone too far. You can't repair it. It's the point of no return. And that could be because it's running hot, it's vibrating, it has seals leaking because they're worn out. At that stage, the bearing ultimately needs to be replaced. And if not replaced, it will fail. Then all we can do is the latter phases is to predict the condition of it using vibration or different types of analysis equipment in order to prevent it from catastrophically breaking down. What we do is that we want to take this point and extend it out here to improve the bearing life. So let's have a look at some of the summaries here. We can say that we know that the lubrication has a direct effect on equipment reliability. We know from statistics that if you've got a good lubrication strategy, you'll reduce the amount of bearings you use because it will reduce wear. You'll use less bearings, and that's a less cost, but not so much less bearings, but more uptime. And more uptime means less maintenance costs, more profit on the bottom line. You'll reduce the amount of lube you consume, again, a reduction in cost and a reduction in the amount of time, because you don't need to replace an oil that is running in a good condition. The end result is you'll improve your business results. So it really comes down to the 6 lubrication right, just to make sure that we get the right lube at the right time, in the right amount, in the right way, in the right condition, and kept in the right condition. If we can do those 6 rights for every application, we will achieve the point of ultimate life, or an improvement in life and the reduction of wear. So in summary, lubrication can cause bearing damage, or poor lubrication can cause bearing damage is probably the better statement. Bearings are the rotating machine center. So if the lubrication works reliably, the bearings will work reliably, and so will the plant and equipment reliability improve. End result, better operating bottom line results. So let's look at lubrication. We'll start reliability. We'll start with the 6 lubes. Why do it? The right lube. Well, there are many different lubes to select from. They have different viscosities, they have different additives, there are different brands, they're not all compatible. And if you mix them, often you'll cause chemical damage and reduce their lubrication properties. In bottom line, we don't want to mix the lube, so we have to have the right lube. The right time. Oil and grease needs to be replenished, but we might forget. There might be a shutdown or an outage, and this can interfere with our schedule, so we may miss a schedule. We may over or we may under lubricate if we're not measuring. And the frequency of how often we add the lube and so forth is application driven. What we don't want to do is to miss a schedule or the right schedule. The right quantity. Speed, loader, and temperature define the quantities we need. We don't want to over lube because we know that will generate heat. We don't want to under lube because we know that can cause starvation. Starvation has an effect on the amount of lubrication film thickness. Do we measure how much we put in? If not, should we be thinking of it? And do we really know how much grease one shot of a grease gun is adding to the bearing? And do we know how many shots or how many ounces or grams we need to add to that particular bearing at what time? In other words, we need to keep the machines fed and fed correctly. And the right way. Oil and grease needs to be dispensed correctly. We don't want to spill anything because that causes problems. We don't want the oil to be contaminated. That's the purpose of Oil Safe, to eliminate that. Still today, many people use open jugs, buckets, same funnels for different oils. These are contamination problems. The quantities need to be measured, and we need to make sure that the environment is protected. In other words, we have to satisfy the environment and we have to satisfy the machines. And in the right condition. Dirty or contaminated lube causes wear and damage. That we've seen with the ISO 446 example, Dr. McPherson's example, and I'll show you a benefit of it in a minute. Dirty or contaminated lube causes wear and damage. We want to use only clean oil. We want to clean it in the storeroom because new oil is not clean. And the new oil can get contaminated within the lube room. Unclean containers pass on dirt. It is really a clinical process. We only want to use clean lubricants. Oil in the machine can come contaminated. Poor quality air breathers. Every time a hydraulic system works, the oil level goes up and down in the cylinder, and hence it draws in air, pushes air out. If the air is contaminated, you're contaminating the oil. So we've got to have good air breathers. We don't want operational contamination, which also can occur. Oxidation can occur, so we need to be monitoring. And are we filtering the machine to clean up dirty oil? In other words, we need to keep the lubes clean. Here is one example, and there are many examples of the cost benefit of a good lubrication strategy. This is one I use from the Port of Tacoma with the work they did in the cleanliness control of the oil in their diesel engines. Here they went from an ISO code of 1916, and this is when they were measuring only 2 components and now not 3 as of today. And they took it from 1916 to 1512, like the example I showed you earlier, and it gave them a 3 times life extension. The mean time between engine rebuilds went from 7,200 hours to 21,000 hours. This gave them a 5-year net gain of nearly $750,000. The rate of return over 600%, and the payback period, if you measured it, 2.04 months. It's a no-brainer. And this information is available openly on the internet. So the strategy. Whenever we look at a strategy, we always look at a number of parts: the lube strategy, the cleanliness control, the database, and the lubrication knowledge. And we also know that as customers get involved, they go through levels: the basic requirement, the lubrication process, the proactive lube part, and asset efficiency. And these are the fundamental strategies or benchmarks that need to be in place for each of those levels. When we do assessments, we often come up with things like this. People do it part and parcel, and it's not common to find, for example, on the strategy, we have a basic resource. We could be doing oil analysis because we have a contract where the lube supplier provides free oil analysis, but we never read the reports. This is typically what happens when we look at a strategy. The point is to put it together in the best practice benchmarks. There are 10 steps really to it, and this we call the winner wheel. And if you look at each one of those 10 steps, these are the things that customers need to do, put into practice to get the 6 lubrication rights working. If you have any application and you ask the 6 questions of that application, and if you find one of those questions is a no, then there will be a problem in the lubrication wheel. We have to assess, we have to plan, we have to manage, we have to have good identification and inspection processes. We need to have a process to make sure only clean oil is added to the machine. We need a good dispensing mechanism. Grease lubrication is an important component of this as well. We have to control the contaminant within the machine. We have to do oil analysis because that's our condition monitoring tool. We have to protect the environment, and we have to make sure that the people that are doing this work know what they're doing. Because again, if they're not, ignorance issues will start to creep in. We do all of these 10 things, but we know most of our distributors in the market don't. Many of our distributors sell our products, and they don't sell the whole package. They sell parts of them. For example, identification inspection. We have bullseyes for sight glasses. We have the Nanetta range with monitoring, oil analysis monitoring ponds. We have a whole range of products, the identification and inspection. Lube storage and cleanliness control, which I'll finish this presentation with, is big with us. Oil safe, it's an art, but oil safe alone is not going to improve your reliability. It's only going to improve one part of it. We also have grease lubrication mechanisms, products, full range of desiccant breathers for contamination control, oil analysis program. And these are all products that our distributors really sell. But our distributors don't really get to this place, to the lube room. And I don't know why they don't get there. Maybe it's because they don't know the questions to ask, or they don't have the knowledge to be able to discuss how to implement a strategy. But the products that are available for an implementation on a lube room today are ready-made and basically put most of the 10 steps of the winner wheel in operation. If you take this Lustor system is one 500-liter system and two 250-liter systems. It cleans the oil, dispenses it, measures it, protects it because it won't allow contaminants getting into it. It uses the oil safe containers with the different colored lids matched to the different symbols, and it uses a wall chart. So if you take the winner wheel and you look at those 10 steps, everything bar grease is really covered if someone buys that. They won't buy that, and that's a ready-made lube room, unless they really know, they've assessed what their situation is. They know this is going to put into effect a planning process, a management process, an organization process within the lube room. They know that will be well identified and it can be inspected, again, with our color coding, here, here, here. It's well-controlled oil dispensing with oil safe. Grease lubrication is a little separate. Contamination control, because we filter the new oil before it goes in. So it starts to create the awareness of the need for contamination control at the machine. Oil analysis, the condition monitoring tool to understand where we are. And of course, environmental control. In European law, you have to have a bund that has 110% of the capacity of the largest container sitting on it. This container here is 500 liters. This is 580 liters. So it's environmentally correct. And training. You will have covered training because you've already gone to the step of understanding all of these things, and you'll only have well-trained people doing this work. And we have 3 different types of lube systems. We have our Lubristation, which is a modified 20 or 40-foot container. These can be heated. They can have air conditioning. They all have power. They have light. They have spill control, an anti-skid floor. They pump out of the supplier barrels. They use pneumatic pumps through a filter. The oil then goes to a tapping bar, which you see in this one, which has a consumption meter. So when you turn the tap on, the pump automatically starts, pulls the oil out of the tank, sends it through a filter to the dispensing tap. And if you want to clean the tank up to start with, you simply turn a tap and you'll over-filter on the whole drum. It is lubrication compliant, customized, self-contained, and professional. The oil safe bulk system, one of the creme de la creme products in the marketplace. You can have it as a basic, an advanced system, everything combined, or as a workstation, and different types of container sizes, and each tank is color coded. So again, lubrication compliant in all aspects except grease lubrication, and it's professional, it's self-contained, and it's customizable to what you want. And then there's the Lustor System. Here is a standard 250 liter container. As you can see on this one, we pull the oil from the supplier drum into the tank, through the pump, through the filter, out the dispensing tap, and we pass the consumption meter. So it's lubricant compliant in every respect. 250 liter. Here is one 500 liter system with 2 types 250 liter system. And we have the wall mounted unit, which pumps directly out of the barrel. This is a lube room. This is 6 lubes in a paper mill just installed recently. 2 250 liter systems, 1 500 liter system, 2 250 liter systems, and another 500. Again, lubrication, reliability compliant, professional, self-contained, and customized. So this gets us to the point today of what we really want with this exhibition. We have many dealers across Europe selling our products, but we don't have dealers that are going into the marketplace selling the concept of lubrication reliability. And if they do, they will get much more than the benefit of just selling a product. But people don't go there because they think perhaps it's too much knowledge. They don't have that knowledge. But if our dealers went out and sold a lube room, a Lustor system, a container, or the bulk system, ready-made lubrication reliability compliant products. And for the very nature of the custom buying that product, they've already started with lubrication reliability. We're looking for dealers that will take us a step further than selling specific products. We're looking for dealers that will go into the market and offer a clean, well-respected dry lube bay. If you're one, talk to us. We want to sign you up. So guys, that's about it. I hope I've covered a lot. Maybe it's a little bit too much, but I'm open for questions. So firstly, thank you all.